today, we're going to talk about a little bit of graphing stuff, and then we're going to just practice solving quadratics, and some of them this time will have imaginary answers. Okay? So I'll review today of things you learned in Algebra 1 and or Algebra 2. Quick warm-up. What do we want to do to number 1? Okay. Can we distribute? Okay. We need to be really clear that we can't distribute, right? Because you would have to square it first before you tried to distribute. And you can't square it and just get x squared plus 1. You'd have to FOIL it out, and you'd get x squared plus 2x plus 1. Then distribute the 3, simplify, subtract 181, get it equal to 0, then see what you could do. Somebody had a better idea. We're going to isolate the squared quantity, and then, yes, then we're going to square root. Good call. 192 divided by 3. Somebody helping me? 60. Okay. So then if we square root both sides, what do we get? Almost. Plus or minus 8. Yep, be real careful. So then if we subtract 1 over there, we get x equals 8 minus 1 would be 7. Negative 8 minus 1 would be negative 9. We good? We could plug them back in here to check. 7 plus 1 is 8. 64 times 3 is 192, minus 11 is 181, etc. Okay? All right. Powers of I. If you were really confused about powers of I yesterday, you can watch Miss Abruzzo's video, just the first 5 minutes of her video from yesterday morning. She explains it differently than I did, okay? She does the remainder thing, okay? If you like that better. She said her class the previous year liked it better. I don't like it better because I can't remember 4 things. Remember, I'm a little slow. So what did I do yesterday? Do you remember? When it's odd, go ahead, Keaton. Okay. Divided by 2, you were right. So this is I squared to the, what would that be divided by 2? 67. Okay. And then what does that give us? What's I squared? Negative 1 to the 67 is negative 1 times I would be a negative 1I. Everybody okay? Okay. This one is even, so we just have to divide by 2. And I squared is negative 1. Negative 1 to the 111 would be negative 1. Okay? Couple quick examples. Dominic, you lost? Okay. Again, if you don't like that, just watch the first 5 minutes of her video. She explained it differently. All right. We're going to talk today about parabolas and graphing. And I want to talk about transformations real quick. The general form for a parabola is just x squared, right? How you know it's going to be a parabola? I don't know if you remember all this stuff, but we're going to have to remember it real soon. When you shift here inside, shift something left or right. Do you remember that a little bit? And when you add something on the back, it shifts it up or down. And when you multiply something out front, it stretches it. And if it happens to be negative, it also reflects it over the x-axis. Okay, so those are the transformations, but this is also called just vertex form of a parabola, where the vertex would be where? H. Okay, so it is the opposite of what's in here, and then you keep what's back here. That's because anything in here does the opposite transformation. Okay, if you think it looks, if it's a positive 2, it actually goes left 2. Right, so this is at the top of worksheet 4. Everybody got whatever they want down off this slide so that you know what vertex form is? Remind me one more time what that A does. It does stretch it, so it could make it wider or skinnier. We talk about parabola. It is actually stretching it up and down. And then it can also reflect, yes, change it upside down if it's negative. Okay. You don't have this. You don't need to write this down. I just want to show you something. Can you even see that? Someone could turn the light off by the phone. I don't know why it's, I created an equation editor in Smart, and it's like so light. I don't get it. I don't know how to make it darker. I guess I can make it bigger and it's darker. All right, so I have these 3 parabolas, and I just want to talk real quick about the oh my goodness, let me try that again. The Hofbauer suggested graphing method, okay? That's not much better, but if you were to put a -2, -1, 0, 1, and 2 in here, you would get 4, 1, 0, 1, and 4, yes? Because you're just squaring it, okay? So when you have a vertex at 0, 0, if you go out 1, either way, it goes up or down 1. If you go out 2, it goes up or down 4 because you're squaring it. Does everybody get that? Okay, so let me graph that red one. Okay. Hang with me just a second here. All right, if we put a 1/2 out in front, we would still square all these numbers, but then we'd take half, right? So 0 squared is 0, half that is 0. But when we go out 1, we square it and get 1, and then it becomes a half. When we put in a -2, we square it, it's a 4. What's half of 4? So it only goes out 2. So this one would look like this. And if you went out 3, squared it, and instead of 9 over here, we would have got 3 and 9, right? Which would have been up here for the red one. What's going to happen with my blue one? 3 squared is 9. Half of that is 4.5. So it at 3 is only up as far as 4.5. So eventually it's going to be wider. Does everybody see that? Okay. And then I did 2 things on this one because I knew you could handle that. If you do the same things, can even put a 3 here, but square this and you get 4, and then you multiply it by -2, right? Square this, it's 1, multiply it by -2, square 3, and you'd have 9 times -2 would be, okay. So this one, the 2 things it does are it makes it skinny, right? It goes over 1 but down 2. And if we go out 2, instead of going down the 4 that you would normally go down, you go all the way down 8. So it is very skinny, but the negative also made it go down, right? Okay. Now, the reason I did that is because I use that idea. Oh, this is just quick review. Notice this had a 1 here, so it was considered a normal width. This 1/3 actually made it wider. The negative 1/10 made it open very wide, or go down very slowly actually, and it had a negative. The 4 was negative, so went down, but it made it skinny. 5 up but skinny. Negative 1/4 down but wider again. The other thing I want you to notice is, where's the axis of symmetry? The line through the middle always goes through what? No? Where's the axis of symmetry go through? It does cross the x-axis, but on the parabola it goes through the vertex, right? And it is, for these parabolas that we're learning today, the axis of symmetry is vertical. So it is x equals equation, and it would be x equals h, because it goes through the x of the vertex. So back to that first slide real quick. You might want to write the axis of symmetry is equation is x equals h. Good? All right. So where's the vertex? We're going to go through these kind of quick. Where is the vertex? Number 2 here. +2, +1. Everybody good? So if I put this at 2, 1. Now, the Hofbauer rule says no matter where we've split it, when you go out 1, you square it, which is 1, and we go up that much, or down. In this case, it's up. Now, could I put in a 3 and a 1 into the equation to find the ordered pairs? Yes. Could I use my graphing calculator if Hofbauer is letting you use your graphing calculator to find ordered pairs? Yes. Okay. I'm just trying to give you some no calculator tips here. It does not have a stretch, so if we go out 2, what's going to happen when we square it? 1, 2, 3, 4. Let's check if that works. If I put a 4 in, 4 minus 2 is 2, squared is 4, plus 1 is 5. Is that where I wound up? Yeah. Okay. When you have the quiz on this, guys, you will have a calculator. Okay. And you will have a graphing calculator, I believe. All right. This one, what's changing? Well, where's the vertex first? -3, -2. And what else is different about this one? Yes, this A is -1. So it's going to open down. But it's still a 1. So when I go out 1, it's still going to go 1. When I go out 2, I'm going to square it, and it means I'm going to shift down 4. So for number 4, where's the vertex? 3, 2, over 3 and up 2. Which way is this one opening? Subtle hint, we'll run out of graph paper, right? It's got to be going down. But this time we're multiplying by a -2. So after we went over 1, we'd square it, but then we'd end up multiplying it by a -2. So it would become what? 2, because we went out 1 and we squared it, then we multiplied it by -2. If you're confused, what is 1 unit over? We could put a 2 in, right? That's the x of 2 here. 2 minus 3 is -1, squared is +1, times -2 is -2, plus 2 is 0. So at 2, it's at 0. If it's that way on the left side, it's got to be that way on the right, yes, because it's got symmetry. The axis of symmetry is going to be at x equals 3 if we wanted to draw that. Okay, if you're liking my little hints at all, we'll see if you get the next point here. If I went out 2, I would square it and get 4, but this -2 multiplies by that 4 and becomes, so it's got to go down 8 from here. 1, 2, 3, 4, 5, 6, 7, 8. Yes, cubic graphs. Yes, eventually we are. All right, let's check if this works. If I put a 5 in, is that a 5, guys? I think so. If I put a 5 in, I'd have 5 minus 3 is 2, squared is 4, times -2 is -8, plus 2 is -6. Is that where I wound up? Was working, right? All right, so can you try 5? Find the vertex. What's this going to be? Wide, skinny, up, down? Up and skinny. Good. I don't think very many points fit, do they? Yes, it is. Thank you. I just can't see that very well. So how much should I go up the first time I go over? Yep. Squared is 1 times 3 is 3. If I go out 2, I square it and get 4, but I go up how many? 12, which would be all the way up to 8, I think. I was thinking that I'm going out 2. It's a parabola, so I have to square it. That's going to go up 4, but that 3 out there stretches it 3 times that far. So it's 12. That's just a little like mental math thing that helps me graph it. I could definitely have put a 0 in because it's where it's crossing the y. And then I'd get -2 squared is 4, times 3 is 12, minus 4 is 8. So I got 0, 8 as an ordered pair. And like I said, you're going to get to use your calculator so you can use the, oh my goodness, that was horrible. Clearly, slight dip in the parabola there. All right. Now we got some fractions. What's going to happen with number 6? It's going to go down, and it's also going to be a little wider, right? So when I go out 1, I'm going to go normally down 1, but this is going to do what? It's going to go half only. Again, you could put in a -3. Plus 4 is 1, squared is 1, times -1/2 is -1/2, plus 3 is 3.5. So -3, 3.5 works. All right, if I went out 2, I'd square it and normally get 4, right? But what's -1/2 of 4? So it's going to go down 2. So if you wanted to check one of those, like it looks like I'm at -6 over here. If I put that in, -6 plus 4, -2 squared is 4. Half of that is 2, but it was negative, so it's -2 plus 4 is 2. It's working. All right, so someone talk me through the last one real fast. Vertex. And what else? If I go out 1, I go, except there's a half, so I only go up half. If I go out 2, I'd normally go up 4, but there's a half, so I'm going to go up 2. All right, you definitely don't have to use my conceptual way if you want to type them in your calculator. Everybody knows how to do that. Just go to y equals, type it in, make sure you do like a Zoom standard. Okay, you do, very important guys, if you're using your calculator, you can't have a plot on if you want to use your table. So you want to go up and hit enter until none of those boxes are darkened in. And then put in, 2x squared or whatever it is. Do a zoom 6 if you want to see the graph. But then you can go to the table. Yeah, I'm going to tell my table to start back at 0 because I don't want to scroll around. There we go. There's some ordered pairs. Everybody okay, one way or another? Anybody having trouble? Dominic, you got a question? So, did it graph? Did you get the table to work? Everything good? All right. All right, we're going to do some practice, and some of these are going to have imaginary answers. So talk me through them. What do you want to do first on number 8? Somebody's going to try to factor this, but is there an n? There's a n squared, no, but no n term. So we can just isolate this. So we'll have 10n squared negative 76. Is that right? Ooh, divide by 10. I don't think this is coming out so nice. But that reduces by 2, right? 38, is that right? Oh, that is disgusting. Who made this worksheet? Okay. Now what? Square root both sides. So we get n equals plus or minus. Okay. In the denominator, I have a square root of 5, which I'm going to have to deal with in a minute. But in the numerator, I have a square root of negative 1 and a square root of 38, which doesn't break down, right? Ooh, what can I do with that? Answer is going to be plus or minus. What is this square root of negative 1 going to become? I. Can't have a square root of 5 in the denominator. Top and bottom by square root of 5. Why does that work? Because it's really just a form of 1, right? All right, so on the bottom I get a 5 because square root of 5 times square root of 5. That's the purpose in doing that. Yeah, 38 times 5. What is it? 190? Thank you. Which is 5 times 2 times 19, so that's not going to have any perfect squares in there. So that's just a disgusting answer. Okay, let's see if this one's any better. Can you try this one on your own? I'm thinking it's better. Is it better? Am I right? Did it come out nicer? What is this going to simplify to? Plus or minus I square roots of 7. Everybody okay? And nobody's going to write I plus or minus the square root of 7. Everybody's clear that that's different? Okay, we're not adding and subtracting. We just have two answers. One is a positive I square root of 7 and one is negative. All right. What about these two? We are supposed to complete the square. Watch the directions. Okay, these are both even. Which one do you want me to do? I don't think I need to do both. Let me do 10. Okay. So what do I do first? Do you remember? Yes, we're going to move. So the x's are isolated and move the 91 over to the other side as a negative and put a blank. Then what? So in this parenthesis goes. Yep. And then square it is 25. Negative 91 plus 25. 66 negative. Okay. Now we square root both sides and we get x plus 5 equals plus or minus. What happens over here? Okay, but it's not nice. We have to leave it square root of 66. 6 times 11 isn't going to fix. What else happens though? Yeah, we got the square root of negative 1 is I. So we have I square root of 66. And then if we add 5, oh no, we're not adding 5. We're doing what? subtracting, so we have a negative 5 plus or minus I square root of 66. Because we subtracted the 5, and this was I times the square root of 66. That's why the plus or minus stayed in here. All right. I'm skipping 11. It says solve by the method of your choice. What do you want to try? What could we do first on number 12? Take out a 2. I don't know if that'll help us. Can that 2 ever equal 0? No. So because it says equals, we really could divide that out and throw it away. If I divide both sides by 2, I get a squared plus a plus 4 equals 0. Does that factor? No, it doesn't. So you want to do completing the square or you want to do quadratic? You want to try completing the square? All right. Good practice with an odd, right? I can do the same problem by quadratic if anybody wants me to, but okay. What would this side be? Plus 1/2. Yes, please use fractions. If you square 1/2, what do you get? Square the top and the bottom, so you get 1/4. Then use your calculator, it's fine. Negative 4 plus 1 divided by 4. Math, enter, enter. This would be negative 15/4. Is that right, guys? Okay, then what? Square root both sides. We have a plus 1/2 equals plus or minus. What happens over here? The negative becomes an I. We have square root of 15, but in the denominator, what happens? Yes, the square root of 4 is just 2, thankfully. So if I subtract the 1/2 over to the other side, it becomes negative 1/2 plus or minus I square roots of 15 over 2. Can I play show and tell? If I had used A equals 2, B equals 2, and C equals 8 and done quadratic formula, opposite of B plus or minus square root of B squared minus 4 times A times C all over 2A, I would have had negative 2 plus or minus the square root of negative 60 over 4. All right. Then I probably would have separated it. Square root of negative 60. Well, there's an I, and 60 is 4 times 15. So I have times 2 times the square root of 15, and that's also over 4. What happens? Negative 2/4 reduces to, and then I have a plus or minus, and back here this 2 goes into this 4 twice, and an I square root of 15 over 2. Okay? So maybe you liked that better. I don't know. I don't usually choose completing the square unless it tells me I have to use completing the square, but it's certainly, some of you like it better than quadratic. I don't know. All right, I don't really have room to do 13. Do you want me to try? Does it factor? I can erase and do it. Anybody get it to factor? What would factors of 5 be at the back? I just have a 5 and a 1. So I'd either have a 9 and a 1 or a 3 and a 3, and they're both positive. I don't think that's going to make a 4 in the middle, do you? I think we're out of choices, so what's left? Do we want to do completing the square here?
No.
We have not ever done completing the square when we had an A that wasn't 1, right? We will eventually have that fun, but for now, I wouldn't. I would definitely do quadratic. A equals 9, B equals 4, C equals 5. Can you try it? You have it memorized? That's probably wrong. I got negative 164 in my head. Is it negative 164 or no? Yes? Okay. Right. We have a square root of negative 1, a square root of 4, and a square root of 41. Right? 4 goes in there 41 times. So this would be 2i square roots of 41 over 18, or negative 2/9 plus or minus 1/9, right? Which could have also been written as one fraction. Questions? Anybody make a mistake somewhere and can't figure out where? Or want to yell at me that I made a mistake somewhere? Is there one that factors so we could practice factoring? Does this one maybe factor? 2v squared minus 11v minus 6 equals 0. If we do 2 and 1 and we put the 6 here, wouldn't that be 12? Yeah. Negative 12 and positive 1 would make negative 11 in the middle. I realize some of you that takes a lot more thinking. So wouldn't have to show that step, but it should be v equals what? Negative 1/2 or 6. What about 16? If we subtract 7n off both sides, we get this. What do you want to do with that? Can we just do the square rooting thing? Because we can isolate the n, right? So if we subtract 4 and divide by 11, I'm kind of skipping steps. I'll have that. Then what? N equals plus or minus. What does the top become? Almost. This is I, but what is the square root of 4? So it's just 2i. And then it is over square root of 11. So Keaton says we got to multiply by square root of 11. So it becomes 2i square root of 11 over 11. Okay. Quadratic would have worked out that way. What would b have had to be if you were going to do quadratic here? On this one right here, b would be 0 if you wanted to do quadratic. All right, is that enough? You get the idea? I don't think I need to do any more examples. Okay, so you're supposed to work on worksheet 5. You only have to do the circled problems. I don't know what numbers they are. Are there circled problems on worksheet 5? Okay. Should I be telling you that I don't think there's any on the quadratic section that have imaginary answers on the quiz, okay? There is a section about complex numbers, but I think that's the only place that there's eyes on the quiz. Now, did I just record that?